Hey guys! Today I'm going to tell you about the Coulomb, the ampere and the volt. When we study electricity, we use these terms all the time, but do we understand what they really mean? So, today I'm going to tell you about them. So, the Coulomb. What is a Coulomb? Coulomb is a measure of charge. We measure charge in coulombs. What does it mean? Well, we start with the elementary charge. The elementary charge is the smallest possible charge. It's the charge of one electron. So, one electron carries a charge of 1.6 times 10 to the minus 19th coulombs. So, what is a coulomb, you ask me? The coulomb is just a bag of electrons, right? How many electrons in this bag? Well, 16 zeros, electrons. So a bag containing this amount of electrons is called a coulomb. So when I say coulomb, I mean a bag of electrons. That's it. So, as we already know, electrons carry a negative charge. The positive charge is carried by the protons. But the protons are heavy and they are stuck neatly inside the nucleus. They don't move much. So, when we say charge is moving, we usually mean that the electrons are moving. So, when electrons are moving in a certain direction, we call it electric current. To understand an electric current, let's build a simple circuit. In this simple circuit, the cell gives the electrons energy. Well, when I say electrons, I actually mean bags of electrons. That is a coulomb. So this is a coulomb of electrons. So the cell gives the electrons energy, and the electrons carry this energy to the lamp. In the lamp, the energy is transferred as light and heat, and then the electrons go back to the cell to fetch some more energy. So, we've discussed what is a coulomb, now the ampere. The ampere is simply how many bags of these electrons, or how many coulombs, flow past a point in 1 second. A device that measures current is called an ammeter. If we put an ammeter into this circuit, it will measure how many coulombs or how many bags flow past in 1 second. So, 1 ampere is simply 1 coulomb in 1 second. 1 coulomb If we put it into a formula, it will look like this. I is equal to Q divided by T. Current is equal to charge divided by time. Or ampere is coulomb divided by second. And now the last thing is the volt. Volt is what we measure voltage in. Also potential difference. Sometimes we say EMF. They're very closely connected to each other, almost the same thing. Let's discuss what a volt is. Now, as we remember, the bags of electrons, or the electrons, go around the circuit and they fetch some energy in this cell, and then they give the energy to the lamp. If we put a measuring device which measures the difference in energies between these 2 points, before the cell and after the cell, we get the amount of energy given to each coulomb of charge. And that's the definition of volt. The voltage is how many joules of energy we give to each coulomb. If we connect the voltmeter to the lamp, we will measure the difference in energy before and after the lamp. So we will measure how many joules of energy is lost by each coulomb of charge as it passes through the lamp. And this is also voltage. So it's the amount of energy per coulomb. So 1 volt is 1 joule divided by 1 coulomb. And of course we can write a formula similar to that. It would look like this. Voltage is equal to energy divided by charge. And in units, that's the volt, which is the joule per coulomb. And now finalizing, I'd like to write out all the definitions. So 1 Coulomb is 6.25 times 10 to the 18th electrons. Well, not exactly, 1 Coulomb is not electrons. It's the charge equivalent to the charge of this amount of electrons. The current. Current is the number of coulombs flowing past a point in 1 second. Voltage, we have two types of voltage. Voltage EMF, it's called electromotive force. It's the energy received by 1 coulomb of charge as it goes through the cell. The second type of voltage is PD, potential difference. Is the energy lost by 1 coulomb of charge as it goes through the lamp. Well, it doesn't have to be a lamp, it could be an electric motor or any element of the circuit where the electrons lose energy. So, EMF is gain in energy, PD is loss in energy. If you want to see my video on Ohm's law, here it is. Thank you, goodbye.